Hello, everyone. Welcome to the seminar. I'm Johnny Lin, co-founder and CEO of Gemini Data, and here with me is Dylan Hedberg, our sales engineer. I'm very glad to be presenting to you and sharing with you the 5 key success to Graph. So what I have here with Dylan is I'm going to present to you, some of our, experiences, and Dylan is going to walk you through a live demo, with some of our suggestions. So let's go ahead into our deck. Okay, so for those of you who doesn't know about Gemini, I just want to give you a very quick introduction. So we're actually based out of San Francisco, and the company has been around for a couple of years, and we've been very focused on modernizing graph technology and define how data is used, understood, and shared, within the enterprise. And that is all based on our AI-powered, context-driven platform that enable businesses to connect the dots, for various benefits. So and we've been, our platform has been used for with quite a variety of customers globally. Happy to share some of those examples at a later date if you're interested. But let's go into our topic today. So first of all, I would assume for those of you who registered to this webinar, you somewhat know about what Graph is, and that's why you're here and listening to this or participating in this webinar. But I want to be very specific about what we are presenting today. So when we say graph, we're not talking about the graph on the left, which is actually a chart, for most people that are in the analytics world. What we are referring to is, the graph on the right, which typically, is formed with, nodes and relationships, right? That's what we're going to talk about today. And we know that a lot of organizations today are, trying to look at graph technology, or they're already in the middle of using it. But obviously, there's been a number of challenges that, as we have spoken with a number of our customers. So let's take a look at that, why people are using it first, and then we'll dive deep, dive deep into some of the challenges or problems that we have seen from some of our customer engagements. So first of all, people use graph technology because they realize that traditional analytics that that we've been using today, like those business intelligence, BI, or data visualization tools, are very static and tabular. They're good, if you intend to use it for like looking at your revenue or your sales numbers, your product sales, those kind of things that are pretty good with these traditional analytic tools. But the problem is, there's a lack of context. Unless that you ask IT or your developers to prepare those upfront schemas or queries, otherwise you will not be able to drill down into these charts or reports, right? And if you look into this deeper, you will actually realize, there are actually lots of contexts that are hidden within those charts, right? And some of those are, of the same thing. Some of those could be different, like giving you different context that helps you, with your decision making. But the fact is, statistical visualization that we've been using all these, past few decades, don't give you the kind of association or connection and relationship, for which helps drive your decision making. And why is that? I think it's important to understand that in the typical enterprise world, data is typically very siloed, because there are different teams, different businesses, different functions. So as a matter of fact, most of these data, are being stored in different places or databases, right? So to have a holistic or like a 360-degree view of your business is just really hard, because you have to overcome these silo data and connect them together before they can give you some insight, right? And to get to those silo data, what you need to do is probably work with your IT or information department, to perform these very heavy data engineering work, which relies on lots of database table joins, right? And of course, this is not something that a typical business user would know or understand how to do. And that is why a lot of these analytic projects or analytic tasks take so long to complete, because just in the engineering of these joins of database table could take you if not days, could sometimes be weeks to get it to work. And not to mention about the performance challenges of getting all these to work properly and deliver the kind of performance that business user expects, right? So as time goes by, the technology has have shifted over the years. And what we are seeing in the market today is that as most people realize about the limitation with those traditional analytic tools, just like the ones that you see on the left on the screen, these are very static, very popular. We've been using this for a long time. No problem there, but there's actually a better alternative and a faster and more efficient, more productive way to use data, especially for those that are a great fit for a graph. So what we are seeing is some organizations have already get into this graph technology world and start looking at or using their data in a way in the form of a knowledge graph, and that typically drive rapid decision making and gives you lots of benefits. So and just to to summarize here for a little bit, that we see graph as a great solutions to help connect the dots for business, because it gives you three really powerful benefits. The first thing is it's able to tell you what's important within your data, and it can do that very quickly. It's also being very good at telling you what's unusual, right? For things like anomalies, things that are out of the norm, it's really easy to pick up with graph. Graph is also really good at telling you what's next, or in other words, giving you recommendations based on the data that it looks at. So it's very suitable for helping you identify those hidden patterns of relationship within your data, within your business, But with all that said, using data, using graph or building a business application or solution with graph is not that simple. As great as it is, building and managing a graph platform or a solution takes all these heavy lifting, with you or having a team to build this out. Whether that you insource or you outsource this, the thing is that you will need to decide, on by introducing one of these graph database platforms, open source or commercial. And then you have to work your way through getting data into the graph database by building the necessary connectors, normalizing the data, learning to use learning to use and deploy those graph database. And eventually you need a graph front end. You need a front end or a user interface that's friendly enough for business users to use, right? And with all that said, you have to also consider all of these security controls, role-based access, collaboration needs. It's a very complex engineering work, right? So I guess the pain that we're seeing out there is that people start to realize how beneficial, how great graph could be, but like building it and making it usable and accessible and valuable to business users is just not that simple, right? So what we want to share here today is to give you some ideas of what are some of the key criteria that could help you get to a successful graph deployment or to a successful graph solution. So the first thing I want to highlight is just like any data analytic projects, right? Translating business requirement into technical requirements, because fundamentally when you're introducing graph capability into the organization, you will need to decide, where do you want to apply graph for, within the organization to solve certain business problem. But this time, compared with the traditional approaches or compared with the traditional solutions, besides identifying the business problems, translating that business requirement into graph technical, requirements is very different. It's you have to decide on, what are the graph elements, for example, the nodes and edges, and what are those when mapping back to your data source, to your data sets. It's and then map that to your business question, right? That's a whole different process, a whole different, skill to master. So you will need to have the right people, then the right process and the right tool to, that allows you to translate those business requirements easily into technical requirements. Otherwise, you will spend a lot of time trying to, structure a development or engineering, plan, which could be really complex and time consuming, right? So here are some of our suggestions to fix this problem, and I think this is applicable to basically any data analytic projects. But of course, the first step would be clarifying your business requirement from the business owners or users, and then involve technical experts early, right? Because usually that could be your data science team or your architect that could help you identify the right tools or solutions, and then use a structured approach, right? Breaking down your business questions into, those data requirements, and map that into a graph, features. That would be really helpful for you to move forward the project. And of course, validate and test, as you move along the project. And then at the end of the day would be collaborate and communicate with the business users, and the technical, team who is tasked to build, that application or solution, right? And this is an ongoing process, and I don't think there's a shortcut, but I think communication really matters, and I think that's one of the success that's really required. Number two, ensure data quality. So now let's say you understand the technical business and technical requirement, and you have an idea of what you want to achieve. The next step is really, get the data, and prepare the data. And here we're talking about preparing the data and prepare them in the format or in the form of graph, right? And this is different than preparing the data and putting it into a traditional relational database. That's totally different process and a mechanism. And why is this important? Because if before you can even query or visualize or use that data with graph, you have to make sure that it is properly structured and ingested and processed, right? And you have to model it in a way that works with the graph, right? And I think there's a number of steps that you need to overcome. The first step is typically you will have to normalize the data, like in so-called, some people call it like you have to go through like an ETL process to prepare the data that works with underlying graph database, right? And then you have to find your way to ingest that data either by learning the specialized query language to get the data in, or use other third-party tools that could streamline and make this simple and easy. Then once that is in, of course, deciding and making sure which part of that data are, configured as entities or nodes versus relationships, and based on that, create those, relationship, that connects those nodes and relationships. So those are really key of, making sure that you have quality data that are being ingested and modeled before it's presented and accessed by your business users, right? And we'll talk. Dylan will talk about that and then give you some example of, how you can actually, do this, with a tool that we provide. So that's one of the key success criteria here. Number three, what we have seen out there after speaking with a lot of customers who are, halfway or beginning their graph data journey, they realize this is a whole other, a whole different new skill, that they have to acquire, and which typically means there is, a very specialized query language they have to learn, and and they have to get used to that, and that's something that usually doesn't exist in most of the organizations today. So there's a pretty long learning curve, and I think it's a matter of, it's fundamental, but that's usually like the very first part of your graph data project. And I think if you're not prepared for this, the graph project could take a very long time, and not even go into production, right? And I'm sure that's not something you want. So, and what happens is, and why is why is this a challenge, right? Because if this takes a lot of training and it's difficult to use, I think what you will realize is, the business users tend not to use this kind of solution or application, because it's usually, it usually means reduced productivity and decreased efficiency, you know and people, and we know people are lazy, and they have some other things to do. Everybody is, we're all busy. So how can we make this simple, so that they can, cross the barrier of learning. That's what we're talking here. So I guess, to make a graph data project successful, I think you will have to consider investing in, front end development, or invest in or introduce like a third party intuitive tools that helps drive that user experience, and making it easier and simple for people to access and use graph data, and keep what's under the hood, because what that means is you don't want the business users to learn all these specialized query language. It's just too hard. It's for developers, right? And because it is meant for developers, how do you actually make it simple for your business users? You don't want them to learn how to use another tool, right? You want to make it as simple as it is. So that goes into our, um, the one of those 5 keys to the success criteria, which is, graphs are better shared, because I think graph is great, but if you don't share it and only the technical users know how to use it, people won't see the value, and it's going to be very limited, and you're not going to take the full advantage of graph. And what we realize, most of the tools out there, they are typically like desktop or client based, single client, single user based, a big desktop tools, right? Which is very hard for you to share views or even collaborate with other coworkers or colleagues, right? So when looking into this type of solution or application, whether you're building out this by yourself or you're introducing a third party solution, you want to look at how good it is in supporting role-based access, and allowing you to, whether or not it allows you to, create knowledge and share that knowledge through, you can take snapshot of what you have created and share that with other people, and allow them to look at what you have, come up with, with a shareable link, like your Google, shareable links, right? We all have that kind of experience, and this is how people are used to using, tools today. And data enrichment. Do we allow users to bring in more data or bring more context to enrich that story or to enrich that graph, with the hope to, solve the problem faster and easier. So these are all the things that you need to look at when developing or working on a graph data project. Number 5, we said that, in number 3, we said about, the typically there's a long learning curve for people to use, get used to using graph technologies, right? And that's because of the specialized query language involved and the different process and experience people need to learn. So with this recent discussion and heat wave of generative AI, like the ChatGPT from OpenAI, actually this has made graph even more accessible than ever, because it used to be that we have to rely on users to learn those query languages or special tricks or methodologies to use certain tools. But today, with the adoption or the integration with generative AI, users will be able to ask questions with human text input, and as a result, with that, connected with generative AI like GPT or others, you're able to get graph data output with context as your answers to that question, and that only requires you to, ask the question, without learning to use the tool, really. And here is a quote that I take from ChatGPT. And I think this is really and super valuable for those of you that are looking at why you should, why Graph is great and why you should take advantage of this kind of technology, especially, in the era of, generative AI. Because as it says here, Graph databases excels at handling complex interconnected data, making them ideal for generative AI training. Unlike traditional relational database that relies on tables, rows and columns, and can struggle with very complex relationships. So, in simple terms, right, graph are like a very flexible, efficient, and easy to understand, web of information that's perfect for training AI models that need to, understand complex connection. So this already tells us that graph could be a great foundation for your AI projects. And I think, but I guess the challenge is how can we make this simple for business users or even for the guys that are building these solutions, right? And I think we have a great answer to this, and that's why I'm going to turn this session to Dylan.
All right, so today we've prepared a few demos to go through, and just to give you guys a little bit of context, we're going to explain each one before we hop into the exploration canvas. So with these two demos, we're going to start off simple. We're going to use a more fun use case. So for this use case I have pulled up here, we have an NBA data set example from the 2022 to 2023 season. And this data was collected prior to the trade deadline this season. And our aim was to help teams figure out what they need to do to help their playoff push or find the direction they want to go to in the off season. Okay. So first thing I'm going to do is take you through our data ingestion process and our data modeling process. And you'll see here we have 5 different flows which contain different data sets and different data models. So a flow is a unique combination of both a source and data model. And to see the data that we have, I'm going to go into this data preview that we have here for this data source. So we have a CSV that we've collected based on their stats on the prior season. And so what we have here, we have player names, positions, age, and other metrics that may help describe the nodes. So the way we data model, we use the headers and CSV files for this example to assign as nodes. And then we use nodes like PER, which stands for player efficiency rating, to use to describe nodes. So some headers are better used as properties to describe nodes. And just to give a little bit of context with NBA data, since everyone may not understand, a player efficiency rating is well used as a all-in-one statistic, which combines shooting efficiency, defense ratings, turnover ratio, etc. Let me go back and cancel out of here. For another data set, let me pull up the player info. And you'll see just right here quickly that we have different plugins that are available for your data ingestion. And we're not limited to only CSV in one project. You could have multiple sources from different data silos. So if you have more dynamic sources such as Splunk or Salesforce, you can automate those ingestions with time increments. But if there's more static data sets that you want to put in place, CSV is generally your best option. So for modeling player info, for example, let's look at the data preview again. And so the way we model, we don't care how you edit or how you label your headers on your data sources. We take you through the process of normalizations through tags. And so just to give you guys an example what a cipher, how to do this with cipher, here's just a small snippet of what you would see generally. And there's obviously a learning curve here. There's some syntax that you need to learn. And even just looking at this, it's not very visual. I can't even tell if I'm doing it correctly from this way. But what we have here, we have a wizard and a DIY step process where you can see what you're modeling and what you're connecting to each other. So I'm going to go into next. So I'm just going to take you through an existing model right now, just to show you what one would look like. So from the headers that you had from your data source, those are all available on dropdowns. And so for example, for the header player, I can just select that here and then add the properties through more dropdowns. And the way we normalize it is through this category right here. So if the player was, for example, named athlete or basketball player, anything else, just player name, the way we show it in our graph only cares about how we label it through tags. So what you can see here that from this data source, we created 4 unique nodes. So for this one, for example, we have team name that has been labeled team, last attended, which identifies as school. So this better describes last attended, and then the countries that these players are from. So here we have 4 nodes created. Under the next process, we'll then define the relationships. And from those 4 nodes that you've created, they're again available on the next page as dropdowns. And here you can start labeling. So for this example, we have the player as now playing on this team. If I go into another relationship, we have player has last attended this school, and then player has is from this country. And on this next example, you can see this data preview, data model preview, which acts as a whiteboard. So if I wanted to make any changes to any of the data model, I can always go back at any time or even cancel and start over the whole process. But here I can make sure that everything that I'm ingesting in labeling and modeling in my data set and data flow is correct before hitting next and then starting the ingestion. So with that, I can save. This one's already saved, so I'm just going to cancel out of this. So we're lowering the level of expertise needed to data model, and it's very visual and it's very friendly. So with that, we're going to go into exploration. And other traditional graph technologies out there require even Cypher knowledge to even search for data. So if I want to go back to my Cypher example right here. So these ones on the bottom would show how you would retrieve the data once you have modeled it. But right here, when we say we're no code, we're truly no code. And so how we would add nodes onto the canvas, there's a few different methods that we'll go through today. And one of them is from our source data list, from the tags that we've labeled from our data sets, we can simply just add the team nodes onto the canvas by selecting the plus button. And from there, we've customized nodes based on their logos of teams. And let's say, for example, I was trying to help a certain team. Let's help the Detroit Pistons, since if you guys are aware of their NBA standing, they're generally in last place for the last few seasons. So sorry in advance for any Detroit Pistons fans out there. But let's see how we can use Graph to help them out. So first thing I'm going to do, I'm going to select the Detroit Pistons. I'm going to isolate that node. Then from there, I'm going to right click to explore their existing players on their roster. And here you'll see the nodes based on who's playing currently on the Detroit Pistons. And you'll notice that these nodes are varying in size and varying in color. So some of these nodes, let me select this guy, for example. We set conditional formatting based on their player efficiency rating, because this one is an all-in-one metric. The ones in red are also labeled with expiring contracts. So if they have no contract planned for the 2023 season, they're going to be labeled in red. So if I wanted to separate this better, let me select all of the player nodes here, and I'm going to add their positions. Okay, and then with that, we have the 5 positions in basketball. So point guard, shooting guard, power forward, small forward, and center. So if I wanted to clean this up, rather than just dragging all these nodes out right here, I can simply click this redraw the canvas, and it will automatically separate in a much cleaner view. And right here, I can gather insights on the Detroit Pistons. I can see which positions are of concern for the next season. So for example, this power forward position, the Detroit Pistons currently have 3 players with high player efficiency ratings that have expiring contracts next year. And since they're low in the standings, perhaps their best plan is to look at the potential prospects of the upcoming NBA draft. So with that, I can sort and select by position, explore the neighbors, and then add the prospects. Okay. With this too, we have the projected 100 prospects that are to be included in the NBA draft or signed to the G League team. So with that, with the power forward position being of concern, you can see some of these nodes that also have a labeled green dot on them. And this data set came from the scouting reports. So for example, I would want to focus on the ones with the green dots since they're projected to have a high draft pick. Those are players that have a high ranking. And with that too, they're labeled in green dots because they have an annotation attached to them. So for example, this guy, Victor Mbiyama, under annotations, I can see a scouting report, perhaps there's an attached video, and you can directly play your video through our option right here. So with that, you can add images, videos, text, anything scouting report that you may have for individual nodes can be added here as well. Let me exit out of this. To make further use of Graph to help this team, perhaps you can use their network of last schools attended to help with their draft or their scouting process. So with that, I'm going to select existing players based on who's playing for the Detroit currently and add their previous schools that they attended. And in most cases, nodes with high level activity are going to be pushed towards the center of the graph. So we have these two nodes, school nodes here. We have Duke and Kentucky for schools. Since March Madness just passed, perhaps they wanted to do this before the tournament to scout these players and see how they do during the tournament. So with that, I can highlight both school nodes here. And with that, I'm going to select neighbors of 2 hops away. So when selecting levels of neighbors, what we're doing, when I say hop, I'm describing nodes that are directly connected and 1 hop also over. And then with that, I'm going to isolate that. And here I can see that we have some players currently on our team that also attended schools with some potential high-ranking draft picks. So here, I may want to send this guy, re-sign him to check out some of the players that are labeled as prospects. So for example, I can send Marvin Bagley since he attended Duke, and there's a lot of players that are attached to Duke. Because sometimes scouting just by their games may not show their work ethic, so this can help with their scouting process. And to share this with our team, let's say I want to save this graph. I'm going to save this as scout strategy. And as it saves, so to make Graph more accessible to even the non-technical users that just want to see the results, what you can do, once you save a snapshot of what you find, the insights you find, you can get a shareable link here, and all you have to do is copy this and share with any of your colleagues. So they don't even need an Explorer account to even access this graph. They can see what you have saved on this visual. Of course, they're limited to not being able to add additional nodes onto the canvas. And what I'll do too is I'll attach this link also to the comments later on, and you can see this graph for yourself, just to prove that sharing graphs has been made a lot easier and accessible. And let me clear the canvas, and then I'm going to select a new snapshot. So we showed how to add canvas based on just selecting one category of nodes. Let's say I wanted to search for specific players. It wouldn't be the best practice to search all 755 players. We would want to filter that down to specify the criteria that we want to bring back to the graph. So with that, we've implemented filtered searches. So for example, if I wanted to search for players with, again, helping the Detroit Pistons look for power forwards, I'm going to type in the tag for player. And you can search for individual nodes by typing in their name, or if I select all players, I can add rules to filter my search. So here, perhaps I want to label their salary of 2023 to 2024 equal to 0, meaning that they have no contract in place. Also, what I may want to do is specify a position. So these are properties added to the players, equal to, and I'll say power forward. So you can enter numeric values or string values. It works either way, and you can add as many rules as you need to filter down your search. So when I apply this here and then search, okay, so what's returned here is power forwards with expiring contracts. You can see them all in red, and based on their size, their player efficiency ratings are higher. So if I wanted to have a draft strategy this way, I can then explore neighbors, add the teams maybe I want to add to contact beforehand. Maybe I want to trade for them now before they're signed in the off season. And so here I can see perhaps Mason Plumlee would be someone that I may want to be trading for. He's now playing with the Charlotte Hornets, but looks like originally he had his contract with the Chicago Bulls. So perhaps there's two teams to be working with to complete this deal if I want to acquire this player now. And now I'm going to move over to our second example, which is a supply chain use case, and just to demonstrate a more realistic use of graph in this realm. And so just to give a little bit of context for this use case, we have a electronic manufacturer based in Taiwan that implemented the supplier data, product builds, their different regions and SKUs that they sell to. And what they want to do is have one centralized view of their entire supply chain process. And so with that, with 3 different models, and this is for an inventory management use case, perhaps they want to make sure they're not overstocking or understocking a certain material based on their product builds. And so with that, if they select the 3 models of, I believe this is video projectors, and then add to the canvas the materials, and then I'm going to redraw the canvas again. Where Graph helps out is they can see the commonalities between these 3 projector models based on what's being linked between all of them in the center. So with that, what we've just done is we have added the shared parts that are common for all 3 model builds. So I can group those into, just to clean up the graph a little bit. So I'll label these as shared materials. So, okay. And then the ones outside may be labeled as unique or special. And so the concern here is maybe not overstocking on stuff that is only unique for one build, because things on the shelves are due to age, and maybe there's a new version that comes out later. And then understocking for shared materials, this group right here is bound to deplete a lot faster based on being sold from all 3 builds. So this could be well shared with the procurement team to see, and their inventory manager to make sure that they have the right materials and right amount of inventory. So the way we make Graph more accessible too, we showed how to add nodes individually, how to add nodes based on search filtering. We've also implemented a way of using natural language to add nodes onto the canvas to even lower the expertise needed to develop a graph. So as a simple example, let me just say show materials. And just using this as if it was like a search engine, I can say search for that. And what we have here, we're showing the material nodes that we have on our data set. And so with that too, I can use this search bar also to select nodes on the canvas. So I'm going to say select materials based on a certain condition, select materials with inventory between 5,000 and 10,000. And right here, we'll see that one of the nodes has been selected. So this node on the bottom right here, let's zoom in on there. So with that, we can see under the profiler panel that the inventory is labeled as 7,000, which meets our criteria set. So we're just displaying how we can search for certain node categories, but this isn't a graph itself. What you can also do with natural language, in our search bar, you can display a graph. So let's say I wanted to do a more complex search, show parts supplied by owls. And you'll see from the search that we have two node categories that we're searching for. We have the part nodes, and also the supplier nodes. And to verify this, I'll highlight the node in the center. We have our first supplier and then the parts supplied by them. And to make this more realistic and useful, what they may want to find out from that natural language search is perhaps this business went out of they gone under, or there's a canal blockage that prevents them from shipping their materials. Perhaps they want to see and start off their search of what's being affected. And they can see their certain part numbers and then expand perhaps to what materials these are labeled as. And with that too, they can expand, maybe find out which SKUs are being affected by them. And with that too, perhaps I can group the SKUs affected. And materials infected. And now I have two groups, which then I can, if let's say certain teams in the supply chain manufacturing were only concerned with this results, you can export this group as a CSV in itself. So this may be useful for the customer support team, and the materials affected could be affected for the supplier management team or the procurement team, things like that. So this graph in itself may help multiple parts of your team in total. And that's all I have for these two demos today.
Okay, great. I hope you liked the demo, and that was just an example how a an intuitive and no-code solution like ours could really help facilitate your graph data journey and make it simple for enterprise adoption. So yeah, if you're interested, we do allow anyone to go to our website and create a free account, and that will give you a 14-day free trial to play with your own data and experience our platform. It will allow you to upload your a limited amount of CSV files as an example, and get you started with a mini project for your own trial. All right, I'm gonna wrap up here and appreciate your time today, and I hope to see you guys soon.